Proceeding.
See?
Proceeding.
Go ahead.
Yeah, where are we going next?
How about figure 25, Pogo and bleed systems bellows. A little bit different. As go around the center of the joint and then the upstream weld and downstream weld. 3 passes over that gimbal, essentially. The highest reading noted.
The OMTO hadn't shown up yet. He was after some Tygon tubing, I guess he wanted.
Bubble soap, maybe?
Oh, he had bubble soap and tape, but he was going to 101 for some Tygon tubing.
Well, I'll find out.
Well, maybe it was a relief tube.
S168.
Copy that, Morris. You sound excited.
I'm thrilled beyond belief.
I thought so.
Are we going to do something here, or are we standing by, or what's up?
We should be back shortly.
Okay.
1279, right?
Right.
These guys, Morris, what we do is we take a background reading, and then we go around the middle of the gimbal, and then on both sides of the welds, and then you just give me the highest reading we note.
Okay.
Over, Kizzy. Yeah, it looks like on this lock side here, you got 2 lines. There's 2 2-inch lines. Is that what you're talking about?
Right.
Okay, and one of them makes an elbow and goes into the 17-inch disconnect. The other one goes down through the...
Right, the one we want is the one that makes an elbow into the 17-inch.
Yeah, that's what it looked like. Okay.
Right. Yeah, the other one is our 2-inch pressurization line, PD4.
Copy.
And that one's kind of ambient right now. If you were to look at the other end, you'd find 3 nice 1-inch lines that bagged and taped, I hope.
That's the firm. No, look, I see caps on the end of them.
Engine interface?
No, there's caps, and then there's 3 that come up off of those and make a big elbow and start on back, but they're not 1-inch lines. They're look like 3/4, half-inch, 5/8 lines.
Yeah, something like that. That's about right.
Okay, but they're capped at the end of the 1-inch.
Oh, okay. Yeah, at the other end of those lines up near the engine interface, they cut those 3 off. The check valves on those were bad.
Yeah, I can see one of them from where I'm at, and it's bagged.
Have some fun with those.
Looks like.
We did the GN2 blowdown on those. It theoretically made it clean. As soon as we cut off the check valves at the end because they failed the reverse seat leak check, we found little fibrous material.
Oh, wonderful.
Yeah. Thank you, Palmdale. Needless to say, it'd be kind of tough to have those Aclarm bag tape hold 400 PSI. What do you think?
Yes, sounds like.
Yeah, they'd have to be real good bags.
Finger over.
Operator, we're ready for a background check, please.
Right.
I didn't mean to wake you up. Just getting comfortable on that radiator cover.
Was that on top of the radiator?
No, it's too high to climb.
Okay. And OMTO, we're going to start on G1. Does that sound good?
That sounds good to me.
That's that gimbal down there in the 17-inch disconnect. Okay.
Okay, are we ready? Looks like, -10 to the -7.
So what we want to do is, there's a reference of what the gimbal should look like on page 38, figure 26. Get in there as close to the bellows as we can, once around the bellows, maybe twice if you feel like it, and then once around the upper weld, once around the lower weld. And mass spec machine operator, we just want to note the highest reading you get.
Copy.
Go CMPS. Whenever you're ready, and I don't believe these have any near a probe in the bellows. That's why I say go around the bellows.
Yeah, no, because they're all, from what I can look, they're all metal bellows for one.
Yeah.
And then they got that metal support around them.
Yeah. So you understand how to do that one, right?
First let me get down here and get positioned so I can get a better look at this.
Copy.
I understand the welds. We go around the bellows. We go around You said around the bellows, on both sides of the bellows? You can do that more than once and then go around the wells, is that correct?
Yeah, if you can. We just want to try and get as much of that thing mass spec as possible.
Okay, alright, I'll just go ahead and I'll stop up everything I can.
Okay, copy that. Thank you, sir.
You say G1, correct?
Right, it's that one right before the 90 degree.
Alright, copy that.
You're just about on your head, right?
That's about where I'm at right now. I'm getting there. Hey, let's go ahead and do the bellows first, and then let's do the wells since that's on the bottom. Work my way on up.
Okay, yeah, just go ahead and do them all. Tell us when you start and when you finish, and we'll get the max reading.
Okay, machine operator, I'm getting ready on this, so I am starting at this time. Okay, just let me know when you're done.
Machine operator, for your information, this is a 1 times 10 to the minus 5 joint, so that's our maximum allowable leak.
Copy. Bottom well is complete. Now I'm moving into the bottom portion of the bellows. This is complete. Now I'm moving up to the upper well. Well is complete. We're complete with the bellows and the 2 wells.
Copy that.
3 times 10 to the minus 6.
3 times 10 to the minus 6 for the maximum reading. Spec machine operator, the serial number, permeability, etc., etc., etc. Those are all the same, right?
Correct.
Okay, copy that.
Oh.
GE2 is the next one. That should be at the next 90 degree bend.
Copy. Okay, machine operator, we're ready for background. Okay. 8 times 10 to the minus 7.
3.8 times 10 to the minus 7. Copy that.
Okay, we're ready. Complete on that. 8 times 10 to the minus 7.
3.8 times 10 to the minus 7. No change.
Ready for background?
Be on G3, the next one upstream, right?
That's affirmative.
You are.
I'm ready for the background here. Yeah, you're in a bad stream there. We're 1 times 10 to the minus 6. Okay, me go ahead and relocate. Okay, try now. 5.6 times 10 to the minus 7.
5.6 times 10 to the minus 7. Copy. And you gotta go.
Let me get read position here. And I'm on the weld. I'm ready to start reading.
5 and 6 on the same line, right on through, is that correct?
Right, they should be upstream of that guy.
Yeah, we copy.
Numbering is probably going to end up being 6, 5, and 4, right?
It's like...
Mine.
Head off. Why is one of them marked gimbal 3 aft and the other one marked gimbal 3 outboard?
It looks like, I'd have to pull my drawings, but it looks like the line kind of starts from gimbal 3, it starts going inboard.
Yeah, I'm wondering if where they broke gimbal 3 aft off there at G3,
yeah.
right above that there's that flange that's shown at gimbal 1 inboard. I'm wondering if it don't pick up and go in sequence, just like it's from that flange.
A second there. Let me pull out my drawings.
I copy. Over, you see?
Go ahead.
Yeah, it looks like that might be a different line entirely. From that flange back, there's no...
Hang on a second. Let me grab the pogo system out and see what it looks like.
It looks like it might be a 1.5-inch line on back further.
And machine operator, we're complete. Okay. 2 times 10 to the minus 7.
6.2 times 10 to the minus 7. Copy.
Again?
Yeah.
Okay, that next line that we got here, we went ahead and located it for you. I mean, if you're ready for it. It comes off your comes off the box beam there.
Right.
And it's just aft basically of your main of the engine itself, and has the flange and has 3 bellows and has looks like we have 145 degree and then goes straight into a bellows, then a 90 degree, and to another bellows.
Okay, a little bit of a turn there, and
then it kicks up or something. T0 someplace.
Okay.
Or no, I think over the side. Look, I think that's one of our thumb. Isn't that one of our thumb?
Side, yeah.
Yeah, it does. It doesn't go T0. It just goes over the side. So it's one of our thumb ports there. To me. Yeah, with arrows pointing in that direction. Yeah. If you want me to get relocated over to that area?
Yeah, go ahead.
Oh, okay, okay, operator, why don't we go ahead and get a background here since I'm at a good location, I think.
4 times 10 to the minus 7.
Go ahead and get relocated, guys.
Good place to get a background for, or we're going to need another background?
He was after you there. I will leave the net for just a second, I'll be right back.
Okay, copy that.
Okay, MPS, this is over to Tech here. Let's go ahead and work that bellows, the most inward, which is right next to the flange by the box beam, by our pogo valves. Be G4.
Okay, yeah, that's on the box beam. Now I know where the lines are. One line goes from down in the 17-inch disconnect up to PV20 and 21, so it goes up to those 3 valves.
Exactly, yeah.
And then the other line goes from PV19 all the way over to the T0.
Back.
Yeah, it does go up to the, yeah, it runs along the bulkhead there.
Now I know where we are. Okay. Yeah, and the one you're going to do now is closest to the 3 valves there on the box beam, right?
That's correct.
Okay, copy that. You ready for a background?
I believe we already got it.
Okay, what was your background, mass spec operator?
3.4 times 10 to the minus 7.
3.4 times 10 to the minus 7, copy that. And OMPO, whenever you're ready, you have a go.
Okay, that's Morris, let's go.
I'm watching.
Yeah.
Yeah, what I'm doing is, could you give me a quick lesson on the pogo valves and their function here?
Yeah. 18, which is the overboard bleed, what it does is during load, we bleed the locks off of the engines. It goes down through the pre-valves, down through the engines, and cools them off with locks. Comes back, we have PV20 and 21 closed, so it's forced out past PV19, the overboard bleed, and into the LOX dump basin. That's essentially your pre-start conditioning. What this allows is the metals in the engine are essentially at cryogenic temperature by the time you try and start the engine. That way you don't get cold shock to the metal. During load, what that allows you to do is just condition the engines to cryogenic temperatures. And we have essentially the same thing over on the LH2 side, except for we have those little pumps. Because the LH2 is so light, it has to shove the LH2 through the engines. And we have essentially the same thing over there. Except for it doesn't go overboard, it just goes back into the LH2 tank. Light, what it allows you is PV19, the overboard bleed, closes. PV20 and 21 opens up. And what that allows is engine running. LOX tends to act like a pogo stick. That's why it's pogo. It's not an acronym, it's actually the word pogo. And if you look on the old Saturn V launches, some of them actually you can see the whole ship pogoing as it goes up the uphill. Because what happens is the LOX starts acting like a water hammer. And it's actually enough to watch the ship go up and down. And so the pogo system allows this pogoing of the LOX to get translated back into the feed line, and that dampens it out so that you cut all that out.
Okay, so it's basically like a baffle, like in a waterbed, basically, huh?
Yeah, it's like a shock absorber.
Okay. Now, without those, from what I understand, that, you know, you could have lost the vehicle, right?
Oh yeah, yeah. What it does is if it gets severe enough, it could actually start taking out major parts. On the Saturn V stage, it was the LOX and LH2 stage with the 5 engines. I think that was like the 2nd stage.
Mm-hmm.
If you talk to Frank, the pad leader out at the pad, he used to work on that. And the middle engine had a pogo cutoff sensor, and what happened is it started to pogo, it would look at it, and when it got past, I think, 25 Gs of pogoing, the engine is actually going up and down and experiencing 25 Gs. It would cut it off. And shortly after that, they installed a pogo system on the Saturn. But before that, they'd just wait until it started pogoing too bad, and then they'd just cut it off. Cut off the engine.
Yeah, a bad situation to be in.
Yeah.
Okay, machine operator, we're all done here, so you can go ahead and give us the final reading.
3.4 times 10 to the minus 7.
3.4 times 10 to the minus 7. This is G5 there, OMTO.
Okay, got it right in front of me here. Let's go ahead and get set up here for a background check. Okay, ready.
2 times 10 to the minus 7.
3.2 times 10 to the minus 7.
Okay, machine operator, we're ready. We're on the weld. Ready when you are.
I'm watching.
Appreciate that bit of information there.
No problem. Had to answer questions. Or it only helps me.
Guess that's what we're here for, huh?
First question to me when he first met me, he said, "What does POGO stand for?" Yeah. I'm not sure if he was testing me or not. I think he was.
Who, Bob? Nah.
Yeah.
He don't test nobody.
Of course not. That was his first question. What does POGO stand for? The answer? It doesn't.
Yeah, operator, we're complete.
There was no rise. Are you in a contained area or not out in the open?
Hard to say anything, yes, you know.
Well, what I'm saying is every time we go for a background, I get a swing reading, you know, somewhere between 2 and 4.4 or so ever, and it sort of settles down. But as soon as you start to take a reading or start to go around a joint, this puppy drops to 2.8 and never moves again. So I'm just getting a little concerned.
Huh, no, like that last one I did was completely now, as far as being enclosed, it's, you know, I got about 3 feet to about 6 feet of opening around it without any type of structure.
Okay, I was just,
So, yeah, no, that last one, you know, now the other one, the first one that we did on there, I'd say, you know, as far as, you know, being contained, there's, you know, you got some components about within about 6 inches of it.
okay, because it's still pretty stable right now, down around 2.6, but every time we go for a background, I get a fluctuating.
Let's, let me do a background again where I did before, and tell me what you get.
Okay, so our max reading there was 2.8 times 10 to the minus 7.
Well, yeah, that's what the reading stayed, but the background was, what, 3.2 or?
Yeah.
Okay, now just take a background here, just you know, just for us, not for the record.
All right, just a second. Staying pretty stable now. It's staying down around 2.8, 2.6.
Okay, now let's do one more time here because I have 2 places here. Now.
There it is. We got to swing up. We're around 4 now.
Okay, that's I guarantee that's probably from our purge that we got coming back off our white coverage on the edges.
Okay.
Yeah, there's a flow coming back here. Yeah, you can barely feel it, but. Yeah.
All right, there was just such a difference in the two. I just wanted to say something.
Yeah, good. Okay, just gonna get a background here. Spot here for the background. All right, for a background.
2.6 times 10 to the minus 7.
Okay, is that our background for G6 there, OMTO?
That is affirmative, and G6 I believe is our last gimbal there before the flange.
Right, and that's 2.6 times 10 to the minus 7?
That's correct.
And you've got to go, OMTO.
Okay, and machine operators, just for a heads up here, this last gimbal is going to be possibly in a high air current flow area.
Okay.
So we'll keep that in mind when we do it.
All right.
On it.
I'm watching.
We are complete there, machine operator.
Okay, it's going to be 3.0 times 10 to the minus 7.
3.0 times 10 to the minus 7. CMPS?
Okay, go ahead, CMPS.
Okay. Need you to go back into the 17-inch disconnect, and Orbiter Q will be working on figure 8 Baker now.
Yeah, I'll be off my headset here to relocate. Okay, CMPS, where exactly in this hole do you want me?
What I'm looking for is things need to know. I don't think it is, but yeah, answers there. On an MT2
49. Yeah, exactly.
Those should be on the feed line itself.
Okay, maybe they're in your front.
They're not on. They're not in the disconnect. They're upstream of the disconnect, and they should have wires coming out of them too.
Yeah, I see one of them. I see MT49.
Okay.
I'd say almost 6 o'clock. So let me go forward here.
Yeah. It's a little bit higher than that.
That's MT48. Okay, I found 48 and 49. And you think it's higher than that? Speed line farther up?
Yeah, it should be tell they might be wrapped in foam, but that's what I need to know is whether or not they're foamed.
Alright. Up by the manifold itself, huh?
Second. You see MPS?
Go ahead.
Okay, these are on figure 8A. OMTO CMPS?
Yeah, go ahead.
Yeah, it looks like they're at about the o'clock or 10 o'clock position and about the 1 o'clock or 2 o'clock position. So they're right up against the 1307 bulkhead, just about, and they're right above the 17-inch disconnect.
So but they're still on the feed line, is that what you're saying, Ken?
Yeah, they're on the feed line itself. They're not on the disconnect itself. They're on the feed line, but they're awful close to the disconnect.
Okay, so they're down low.
Right.
Okay. So they're below our bellows that we checked earlier.
That's correct.
And then there's that pneumatic package down there.
Oh, of course.
Of
They
course.
should be above the pneumatics package.
Okay, let me climb on down here. You say 1 o'clock and 11 o'clock.
Yeah, about those positions.
What's the view you're looking at here?
Figure 8A on page 14.
Okay, I see 3 views. And E?
Rev O is an Oscar. B, right?
Wait a minute, I've got a page 12 to a page 15. I got a page missing here. Hang on a minute.
Okay.
Okay, I think I found here. Let me climb on down here on my head to identify them.
Don't we find comfortable positions for you?
Oh, yeah.
Electrical D-mate by chance? Oh, okay. Well,
My third card's out there in the OSC area.
oh, okay. See if you can find these first, because I need to know whether or not they're foamed.
Over QC, I'm afraid you got me handicapped here. I don't have any page 13 or 14.
Oh, okay.
They apparently were not in the book,
It disappeared somehow.
I guess.
Well, I'd fax you a copy, except for this one's so bad it's just barely readable as is. Okay, well, the wires that these go to should be marked as MTJ1 and MT2J1, MT1J1 and J2, MT1J1 and MT2J1.
I'm going to take my headset off here. I got to squeeze my head here.
Okay.
J1?
Right. And MT1J1 is on the other side. Should be on the inboard, and MT1 should be on the outboard at about the same position.
Has them located.
Okay.
And what are we going to do with them?
Are they foamed?
No, they're not.
Okay, they're just metal fittings?
They're just metal fitting.
Okay.
Now, Ken, I got a green tag on the MT2J1.
Okay, what does the green tag read?
Reads that it's connector's not safe to wired.
It's what?
It is not safe to wired.
Oh.
Plug not safety wired on 17-inch feed line, yeah. Connector and plug. Well, I think I must go to something else. Hold on. Going right into that. I didn't look at it. Hold on. Off comes the headset.
Okay. What I need you to do also is check your cert card, see if you got electrical D-mate, and if you do, then we want to D-mate those two. And Orbiter Q, I'll give you the entire number that I have in front of me when you're ready.
Yeah, CMPS, this is MTM.
Go ahead.
Hey, listen, I got these Sparkies here within shouting range. Instead of me climbing out of here and...
Oh, okay, yeah, that's fine.
Okay, let me go and ask them if they can do it. Now, I'll put them on the net and talk to you. Now, this one is safety wired. The plug itself, the connector is safety wired to the female receptacle there. Now, I don't know what this critique here is on. Says that the connector and plug are not safety wired to the feed line. Now, whether they have to be safety wired to that flange, you know, where the 6 volts attached to the feed line. If that needs to be safety wired or what, I don't know. But the other one that's at 11 o'clock position,
Right.
that's identically configured the same way, and it does not have a description card hanging from it. So I don't know why they would critique one and not the other.
Probably because they didn't know there was one on the other side.
Yeah, that's probably so. Anyway, I'll go ahead and call these guys over, see if they can help out here real quick.
Okay.
Starbreak, you say?
Go ahead.
Yeah, now these connectors are safety wire, do you understand that?
Okay. Do you guys have dikes?
We'll have to arrange to get them here. Hang on.
Okay.
These demated.
Right, that is correct. And when you're ready, I'll give you the entire number.
MPS, they'll be over in a couple seconds here.
Okay, copy that.
MPS, can you give me the number for MTJ1, please?
Okay, copy that. 50 Victor 41, MT1J1 from 50 Victor 77, Whiskey 33, Papa 783.
You give me that Papa number one more time, please.
Copy, 50 Victor 77, Whiskey 33, Papa 783.
Don, our quality here says it's supposed to be 91 over here. That's what's reading, 91. 91.
784?
783.
Because I have Whiskey 91, Papa 784.
Okay, maybe we got a wrong number here someplace. Hold on. That is the correct one there.
The number on it again?
1 Papa 783. 91 Papa 783.
Okay, and the other one's probably Whiskey 33, Papa 78. Give me the other number. MT2.
Is Whiskey 91 Papa 784.
Okay, they're both 91s then. Okay, I'll pen and ink the thing up here. It should be a 91.
Okay, so we're still on the right connectors?
Right, 50 Victor 77, Whiskey 91, Papa 783 from MT1, and Whiskey 91, Papa 784 from MT2. So just give me a T and a Q when you've got that complete.
MPS, can we verify that there's no power on these connectors?
Yes, sir. That was my safety step prior to that. There is no power on that.
Okay, I appreciate that. Let me go ahead and break the safety wire on here, and then we'll go and get these things demated for you. I'll get a T and Q on you.
Okay, copy that.
Back.
Go ahead.
Yes, my relief has arrived again.
Copy that.
Matt, back shortly.
0.68.
Copy, com check. CMPS.
Starbreak, you.
Okay, we call up SIG for scan deltas also, right?
That's true.
Okay, we got that one demated there at the 1 o'clock position. Don, what number was that?
The 1 o'clock should be MT1.
I think that was 2. It was the Papa 784.
MT2.
Yeah, MT2's there.
Okay.
We're going to have to get out of here, I think, and get some caps for these things now. I mean, we can't leave them open.
Okay, well, I'll have, all we have to do, though, is just turn around and remate them after we do these 2 mass specs on them.
Well, then we're going to have to go get some safety wire and safety wire.
Bring that up to you. N32?
Looks like it's 20.
N20? Okay, I'll call Ash Shop and have bring you up a roll N32 and a pair of, N20, I mean. Hang on a second. No problem.
Put me in an area I don't want to be in. We got this one off. Why don't we go mass spec this one side? Go ahead. This is MPS. Yeah, that's fine. When you're in position for a background, let us know. Hey, John. How you doing? Fine. I'm ready for a background.
Yeah, mass spec operator. The background is times 10 to the minus 7.
Copy, 5 times 10 to the minus 7, you gotta go to your joint. Okay, now we go to the joint, and exactly where you want us to mass spec this thing, John? Around the flange, around the connector, you go around the seal where the connector, where the deucer goes in, and also on the connector itself. Okay, copy that.
Do those Sparkies have,
They're all gone.
Oh, they're all gone? Okay, copy that.
going to be coming off, so my quality will be talking to the machine operator.
Copy that.
I guess you're going to have to go down to your toolbox to get the safety wire pliers. What we'll do is they're going to scrounge up some N20 safety wire, okay, for you, Rob? Okay.
And he's on the joint now. Herbert QC?
Go ahead.
Yeah, why are we demating the connectors to do this?
The Rockwell told us to.
Mass spec the connector itself inside.
Actually, if the deucer can crack and fail internally, and there's a leak path that will come right out the electrical connector.
Okay, so you want it around where the deucer mounts onto the 17-inch disconnect. Then you want it around the connector itself where it goes into the deucer, and then in the center of the deucer itself where we just demated.
That's affirmed.
I copy.
We found some failed deuce, the ones we found on the feed lines. That's how we found them, by mass spec and the electrical connectors. The valid reason for doing this.
Questioning, we just wanted to understand. Mass spec, we're done.
There was no indication of leak there. So the background was your max reading? That's correct, and the mass spec operator at this time is 1457. 1457.
You ready to remate the connector at this point?
That's affirmed. You have a go to remate the connector.
We copy. Over QC?
Go ahead.
Yeah, what do we torque this connector to?
10 connector?
Negative. It's a screw on. Shouldn't be safety wired.
Stumped the panel on that one. I was under the impression that you just installed those hand tight and then you lock wire them. All them with a specific torque.
That's what we're trying to find out here. I very rarely mess with these, so I mean, to be honest with you, I can't tell you.
Yeah, I was under the impression that you torque them hand tight and then you lock wire them down so they can't come undone.
Well, as far as torque wise, when I took it off, there wasn't any torque on it, so if it's anything, it wouldn't be no more than 20 inch-pounds, which is hand tight anyway.
Yeah, that's the way I understand it, and that's the way we've done it in the past. That's why we didn't specify any torque, it's just hand tight.
Okay, well, you guys are running the show.
What I'm going to do is just run it down hand tight and then lock wire.
Yeah, that's affirmed.
Ready for the other connector here, MPS.
The other one?
Yeah, that's what you want us to do.
Yeah, go ahead.
And what I'll do is because I need a pair of safety wire pliers, or a pair of bikes, anyway to re-safety wireless, so we'll just go ahead and demate this, do a mass spec on it.
Have you mated the other one yet?
Yeah, I certainly did, Ken.
Not safety wired.
Okay. Just looking at the paper here, they have do we normally have NASA on remates of connectors?
Both ways.
Okay.
I know we've done heat shields, on the up there, and we don't have NASA on that.
It depends on the QE that's coating the paper.
Okay. Well, I just noticed we need a NASA on this thing for remating.
Better demate the other one again before we call them.
Right. Exactly. And I'll call up NASA for you.
Yeah. Okay, machine operator, we're ready for a background check here.
Fluctuating around quite a bit where you have it at this time.
I'll relocate it here for you. That's right now. MPS, I have the other connector demated as well as the one we were just working on, so we're back to our demate configuration on both connectors.
I copy. Mass spec operator, the background at this time is 4 times 10 to the -7. Copy, go to the joint.
Copy.
And your NASA QC is on the way.
We copy.
And appreciate your help on that. And, I'll leave you with with Mr. Heron here.
Yes, it's home to you.
Go ahead.
John, is that N20 safety wire that we talked to Ken about, is that on its way up by any chance? And if not, have them send up some safety wire pliers with it.
Again, please.
Ken was going to call down to our ass shop and go ahead and have them send up some safety wires so we can re-safety wire these.
Right.
And if he hasn't done that yet, put an order also for a pair of safety wire pliers so I can cut this stuff.
All I need from you is what toolbox you're working out of so they can sign your pliers out of proper toolbox.
Believe it or not, there's not one assigned to anybody back there on third shift, so they can take it out of any box they wish.
Because Ken called down and that was what they asked us, is what toolbox were you using.
You gotta be kidding. It must be a first shifter.
I didn't make it up.
No, it's gotta be a first shifter down there in Nashville. What time is it, 5:30?
That's the firm.
It's first shift, that's first. Have them page Bill Street and he'll take care of it.
Okay, you guys are in, what are we in, high bay? What high bay are you guys in?
We're out of one, I think, now.
Alright, what's your app shop number?
5080.
Alright.
Operator, we are complete on our mass specking here at this time. You can go ahead and take your final reading.
Alright, copy. We have no indication of leak there. The highest reading will be the same as the background. MPS copy. There, MPS.
Head MPS.
I called the app shop again and I got Casey Woods.
Yeah.
And he says that you still have to sign out a box, and I'm not inclined to argue with Casey, so I guess you're gonna have to do it.
Give me a break.
You'll have to go argue with him.
Can you get pad leader and have him page Bill Street?
All right, I'll do that.
Thanks.
Do you see any NASA QCs looming?
Yeah, he just showed up. We can go ahead and get these mated here with your approval.
You got my approval, and I can verify that there's no power on them.
Okay, thank you.
On the other channel for a minute.
Okay, thanks, MPS.
6-8.
Yeah, Pat, would you please page Bill Street, 1787? Oh, MPS.
Okay, go ahead, MPS.
I think that you'll get your pliers and your wire now.
I knew I would. Thank you very much, here. This time, NASA's inspecting our connectors areas.
Copy. Normally have scan on third shift? You get scan numbers on third, or do you not?
After 6 o'clock, my calling for me.
Okay. Man.
Mass spec.
Go ahead.
Yes, is the mass spec operation going to go into first shift? Do I need on-station relief, or?
I'm gonna find that out right now, and I'll get right back to you.
Copy.
MPS.
Go ahead.
Yeah, I think we're gonna get relief on station for the techs.
Copy.
So, do I need to call somebody for you?
No, my relief will go upstairs and tell them I need somebody here.
QC.
Go ahead.
Give me the sequence and step for the NASA to on this mate.
That's the firm. It's Victor 1009.04. 20. Step 6 Echo.
Step 6 and what?
6 Echo.
6 Echo. Thank you. For both connectors?
That's the firm.
Okay, CMPS is on to you.
Go ahead.
All right, John, we got both connectors made at this time. Our NASA, he's going over the paperwork here. He might want to talk to you as far as what kicked us all off. And I'm going to go ahead and state to all these suckers.
Okay, what's the T and Q and N numbers, just so I know, make sure I get them right?
Yeah, tech is going to be 2553.
0. November for NASA.
Okay, so I got to go to state to wire these, I guess?
That's confirmed.
Sure you want me to?
I'm positive.
I can't wait, huh? I'm going to be off the headset here while I do this.
Copy.
CMPS, you have 1 down, 1 to go. CMPS is on to you. The other connector is state to wire this time. And listen, John, we haven't had a break since lunch, and I need to use the facility. So if we can take a short time here so I can do so, I'd appreciate it.
Okay, I guess that's as good as argument as any.
Exactly. Yeah, we'll be off from that here for a little while.
Yeah, I've arranged for on-station relief, so you should have some people showing up between 6:30 and 7. You guys leave at 7, right?
That's correct.
Who you talked to in quality?
I talked to Casey Woods, first shift, I guess he's app supervisor or something like that, and I told him to arrange it, and he's already got some techs in, so they should put it on the call sheet.
quality, I assume.
Yeah.
I told him I needed quality.
Okay, well listen, okay, when we're out, we'll go ahead and follow through on that.
Yeah, you might want to check on it.
Oh yeah. Okay, listen, we'll be off there for about 10, 15 minutes, and we'll get back with you. John.
I copy that. Mass spec, do you copy that?
I copy.
And again, just want to verify connectors are mated and safe to word.
I copy, thanks.
Okay. I'm off from that.
Mass spec off on that.
Hey, the MPS is on to back on station.
Copy.
Listen, we got a first shift here coming in here. And I got someone right behind me. Honey, if you want to go ahead and talk next, I can go ahead and relay it to them. Let's get them started.
Well, we got one more joint down in the bowels of the LOX disconnect, and that's on figure 3.
Figure 3?
PD1 alpha.
Let me find that. My quality's not here yet, so we're still going to need him. I can see that right now.
Yeah, I don't know if Mass Spec's back either. Mass Spec, you back?
Anyway, PD3, figure 3. And what was that PD number again?
PD1 alpha.
PD1 alpha, yeah, PD1 alpha right there. Ooh, that looks like a fun one. Is this a valve or is that another connector?
That's just part of the actual valve itself. It's just the end of that follower arm, which on the lock side is visible. It's called a follower arm end cap.
So follower arm?
Right, that's its official title.
Okay.
But to you, it's just going to look like a green bump. Connect.
Stand down here. Is it on inboard, outboard? I can't really tell by this.
Outboard.
Outboard? Okay. It looks like, yeah, okay, it's more forward and then it runs outboard.
Yeah, that's the front. It goes across the whole forward end of the disconnect.
Right, it looks like it has a 9/16 cap at the end of it or something.
Yeah, and that's what we're doing, the cap there on the end.
Okay. Okay, at least I know where it's at. Okay. Plate that goes over top of it? Is it a plate that goes over top of it or something? Looks like it has a screw or something. Screws, I can't really see it too good.
It's just the end of that. There's a cap on the end of that thing.
Right, there's a cap.
Hold on a second.
And then between the cap and the green bump looks like a plate.
Yeah.
Operator, we got station?
Come back on station yet.
Yeah, me either. Okay, John, now this thing here, it looks like that on the plate itself has a couple teeth on it. Does that thing rotate or something?
So.
Drawing shows it. Does this drawing show the three teeth on it? Looks like there's 3.
Hang on a second. I'm talking to scan.
Okay.
Control requeued on station.
Bobby.
We had in the procedure.
Spec operator on station yet?
Yeah.
Okay, Joe.
Yeah, CMPS is unsealed. This is where I got my first shift relief here.
Okay, you want to time in on what we're going to do, and then we'll go ahead and get started.
I already have.
Okay, then as soon as they're ready, we'll get in position for a background, and we'll start on that joint PD1 alpha.
Okay, while he's climbed down there, you can probably go into your background. That's far enough away. This is third shift here up in that here. See you later, Johnny.
Work you. Yeah, where are you picking up at?
Okay, I have the book up here. I'm binding up here. We're doing mass spec leak checks, and we're starting on with figure 3 with joint PD1 alpha. We're all in, everybody's in position, pressure's up, and whenever you're ready for background, let us know, and we'll get started.
On figure 3 here. What's it on?
What do you mean, what's it on?
Yeah, ET area or?
That's the LO2 17-inch disconnect.
Okay. That ain't figured in the book here.
Figure 3?
That I don't have any figured in the front of the book.
The technician was using them. They must be there somewhere.
Oh, what sequence are you on? Maybe
sequence 20. We're referring to the figures, so it must be there somewhere.
One stuck in the back here in the sequence. I guess that's it. Page 13. It's the background out there already.
Ground looks like 3.8 times 10 to the minus 7.
Okay.
Then you gotta go to the joint. E1 Alpha on figure 3. We're on the area this time. Copy.
Back off the joint.
Copy. The high scale reading is going to be 5.2 times 10 to the minus 7.
Say again, please.
That'll be 5.2 times 10 to the minus 7.
Okay. Joints are transducers. We'll start with X300. You need to refer to figure 8 Baker.
If the mass spec probe operator is 1536.
Baker, what was that joint again?
Figure 8 Baker, that'll be joint X300.
See that?
And that is a transducer. Be foamed, or I don't know if they're foamed on 105 yet or not.
Okay, the LO side is not foamed.
They're not foamed yet?
No, it doesn't get foamed. It's not, none of it's foamed over here.
Okay. I think it might get foamed later, but I don't think they've gotten around to it yet.
I copy.
Okay, so yeah, it's X300, and that's a transducer, and the ID on the transducer, and to verify that, is 50 Victor 41 MT48.
The MT48. I have to be in work relocating.
All right. Mass spec, I didn't catch your T number. Could you please give that to me again?
1279. Yes, be advised, you're probably going to have a little downtime at the beginning of the first shift because this machine was carried over from second, and beginning of a new day, they'll have to re-standardize the machine.